All right, this is the video on finding a polynomial model. If you turn to page 2 in your notes, down at the bottom is the section on polynomial models. The purpose of this video is to try to figure out, if I give you a list of numbers, what would be an equation for that list of numbers. Now, the one that I gave you is a pretty easy list. I'm pretty certain most of you could figure out an equation, but eventually I'm going to give you a more complicated list and ask you to find an equation for that. Well, most of this is going to be done on your calculator. So if you take a second and grab your calculator, and just a side moment here, this is a video obviously, so if I ever speak too quickly or move too quickly and you miss something, you can always pause it, or you can rewind it, go back, listen to it again, and hopefully figure out what you missed. So on your calculator, we have what are called regression equation. A regression equation is the line of best fit. So if I hit Stat and I go over to Calc, you have a whole list of them here. We've been in this menu quite a bit. If I go down here to number 4, I have a linear regression line. So linear, that means that it's a power 1. This equation would have x to the power of 1. The next one I see is a quadratic regression line. That means the equation that I'm going to pick is going to have a power 2. Same thing for number 6. Cubic regression means power 3. Quartic regression means you're going to pick an equation that has a power 4, and I believe that's as high as it goes. Yep, after that you get some other options. So the million-dollar question is, when you look at a set of numbers, how do you know which equation do you pick? Is this data linear? Is it quadratic? Is it cubic? Is it quartic? Or is it something else? So how do we know which one of those equations to pick? Well, here's how we know. Someone discovered once upon a time something called the polynomial difference theorem. Here's how the polynomial difference theorem works. Is you take differences until you get a constant difference. Until you get a constant difference. We'll talk about what that means in just a second. So you're going to take differences until you get a constant difference. The number of differences is going to be equal to the degree. So however many differences you need to take in order to get a constant difference, that's what is going to be the degree. Remember, the degree is the biggest exponent. So here's how this goes. First of all, when I have this here, we're going to take what's called a first difference. A first difference means you look at each term. So and you look at these two numbers and you just subtract them. Difference means subtract. So I'm always going to go the number on the right, subtracting the number on the left. So 4 minus 1, that's a 3. I'm going to go here. I'm going to go 9 minus 4, that's a 5. 16 minus 9 is a 7. Subtract those for a 9. Subtract those right here for an 11. This is a first difference. Okay, the question is, do I have a constant difference? The answer is no. Yes, I clearly see a pattern that it's going up, 2 each time. But a constant difference means you're literally getting the same number over and over and over again. So if I take a second difference is the difference of differences. So in other words, I take these numbers here and I go 5 minus 3, that's a 2. Take these, go 7 minus 5, that's a 2. Subtract those, that's a 2. Subtract those, that's a 2. This would be called my second difference. And I have what's called a constant difference. You have the exact same number over and over and over again. That means we have a constant difference. So what that tells me, I took two differences to get to my constant differences. That tells me that this data, the degree, is equal to 2. Well, things that have a degree equal to 2 are called quadratics. So I'm going to go on my calculator now, and I'm going to enter this data, and I'm going to figure out what the equation is going to be. Here's how I enter it into my calculator. I'm going to call this the first term. This is the second term, the third term, the fourth term, the fifth term, and the sixth term, like that. So list 1 is going to be my term numbers. 1, 2, 3, 4, 5, 6. And list 2 is going to be the actual numbers themselves. So when I go to my calculator, you can get that out one sec. And I'm going to say, all right, let's go edit our list. Hit edit. List 1, I put in here 1, 2, 3, 4, 5, 6. List 2, I put in 1, 4, 9, 16, 25, and 36. Go ahead and pause the video one sec if you need a second, but put all those numbers into your list. After I have them in my list, I'm going to hit stat, and go over to calc, and now you have to pick which type of an equation it is. Well, because I said that the second difference gave me a constant difference, that means it's a power 2, so I'm going to choose option number 5, which is a quadratic regression. I know the equation is quadratic because of the second difference. I hit enter. Depending on your calculator, you might have a different looking menu here, but I hit enter again. And here's what it says. Here's the base equation, ax squared plus bx plus c. Tells me that the a value, it's 1x squared. This is a weird thing that happens. I don't know why this comes up. But this is basically 0. This is point, there's 11 zeros and then 2, it should be a 0. I wish it was. And then this is a 0 as well. So I'm going to take the b, plug 0, take the c, plug 0. So these are canceled out. So the equation here is just y equals x squared. And we kind of knew that. So here's what this lets you do, is it lets you find future terms. I can check my equation 1 second. If I plug 1, square it, you get 1. Plug 2, square it, you get 4. Plug 3 and square it, yep, so it works out. All right, how about you pause the video and try this one. See if you can figure out what's the degree of this, and then find it on your calculator as well. So pause it, see if you can figure it out, and then we'll take a look in just a second. All right, I'm going to take a first difference, 8 minus 1 is 7. Second difference, looks like it's going to be 19. Take this difference and go 64 minus 27 gives me 37. And 125 minus 64 gives me 61. So clearly, no constant. All right, after the first difference, we still don't have a constant difference yet. So let's take a second difference. So we'll go subtract these, get 12. Subtract these, get 24. Subtract these, sorry, this is 18. Subtract these, get 24. Like that. So we're starting to see a pattern, but what we don't have is we still don't have a constant difference. So let's go to a third difference. And when we take a third difference, here's a 6, here's a 6, so we see, hey, we're getting the same number over and over again. That's our constant difference. So what I know from this is that this is now a degree of 3. So we know this is a third degree polynomial, so I know that on my calculator, that's the equation that I have to go use. So on my calculator, I'm going to hit stat and edit. Let's take a look at our list. Just a reminder, the list 1 is going to be which term we're talking about. So term 1, term 2, term 3, term 4, term 5, like that. So go to list 1. I have some extra numbers in here. Let me get rid of them quick. So 1, 2, 3, 4, 5. Over here are going to be the numbers that were in the sequence. So 1, then an 8, then a 27, 64, 125, and get rid of these extra numbers in there. I'll do a quick double check just to make sure these numbers match what's there. Yep, looks like I'm all set. So now I'm going to go back here, hit stat, go over to calc. Because it was a third degree, because a third difference means that it's a third degree polynomial, I'm going to go down here and pick number 6, which is a cubic regression equation. So go down there, pick number 6, hit enter. Once again, we get these numbers that are annoying, but this basically, all of these mean 0. So A is going to be equal to 1, B is going to be equal to 0, C is 0, D is 0. So really, this is just y equals 1x cubed, and I kind of knew that just by looking at the numbers, but now our calculator tells us that as well. So the equation is y equals x cubed, like that. If you want to double check your equation, it's not difficult to do. You just have to take these numbers, plug it in. 1 cubed, 1, 2 cubed is 8, 3 cubed is 27, so you've got your equation. All right, those were a couple easy ones. Let's look at page 3, where it's a touch more difficult. Up on top here, we have a scenario here where someone goes to a party and they want to know how many handshakes can be done between the given number of people that are there. So if we're at a party by ourselves, it doesn't sound like a very fun party, but let's just say there's just one person there, and assuming you cannot shake hands with yourself, we want to know how many handshakes can go on. So one person, you can't shake hands with yourself, there's going to be zero handshakes at that party. Now, let's have another person show up. So now there's 2 people there, and we're thinking about how many people can shake hands. Well, 1 can connect to the other one like that. So it looks like one handshake between two people. Third person shows up. So now that there's 3 people at the party, there's one handshake. Now these people can shake hands, so there's 2. But these people, so now we have 3 handshakes right there. Pause the video 1 second. See if you can fill out the rest of the table. See if you can figure out how many handshakes will go on between 4, 5, 6, 7, 8 people. Once you get into it a little bit, you start to see that there's a pattern. So when the 4th person shows up, you shake hands with all those people, minus 1 because you can't shake hands with yourself, so there's going to be 6. Then 4 makes 10, 15, 21, and then 28 for the total there. And that kind of makes sense because every time, say, another person shows up, that means that we can, there's 5 people that can shake hands, but you can't shake hands with yourself, so we're only going to add 4. Another person means 6 more handshakes, but you can't shake hands with yourself, so we're going to add 5. So the pattern sort of does make sense once you think about it. Now let's say, all right, there's 100 people at this party, and I want to know how many handshakes can go on, and you do not want to fill out this table all the way up to 100. It would take forever. So we're going to see if we can find an equation. So the question is, what's the degree of this polynomial, of this equation? So let's start taking differences. We have 1, and here's 2, 3, 4, 5, 6, 7, like that. So we see a pattern, but we don't have a constant difference yet. So now do it again. We have 1, 1. Now we have our constant difference. So that 1 over and over again. So we know that the degree is equal to 2. Like that. So now that tells me what equation to pick off my calculator. So I'm going to go to list 1, put these top numbers, list 2, put the bottom ones. Let's do that 1 second. So I'll hit stat, go to edit. Right here, list 1 is going to go 1, 2, 3, 4, 5, and then it also has 6, 7, and 8. This list over here has how many handshakes can go on. So 0, and 1, and 3, 6, 10, 15, 21, and 28. Got those numbers right out of the table. After you have that, now we can figure out which equation we need. I'm going to hit stat, go over to calc. Because a second difference is the one that they gave me a constant difference, I'm going to go down to number 5, which is a quadratic regression, and pick that one. Now this one's quite a bit better. The numbers work out better. So I know that A is going to be 0.5, B is going to be negative 0.5, and C is going to be 0, so I can put those numbers right in the equation. So I have y equals 0.5x squared minus 0.5x, like that. And now we can input the number of people at the party and output the number of handshakes that can be done. So if we had 100 people at this party, I can just plunk 100 there and there. So we have 0.5 times 100 squared minus 0.5 times 100, like that. Hey, it looks like there's going to be 4,950 handshakes at this party, and hopefully they all use hand sanitizer. Anyways, have a good day, and hopefully you can figure this out.